Hello everyone, welcome to my channel Code with GD. I am Gourav and I have spent the last 9 years creating software, both as a student and as an engineer. And today we will discuss the famous N-Queen problem. It is one of the standard problems that involves backtracking, and it is essential if you are preparing for interviews. So this video requires a prerequisite that you should know the basics of recursion. If you don't know recursion, don't worry. You can check out my video on the basics of recursion. The link is in the I tab above. So let's get started. The problem says that, let's say you are given a chessboard and an integer n. You need to find all the possibilities of placing n queens on the chessboard. Now don't worry if you don't know what a queen is and how it is placed on a chessboard. I will tell you about it. So a typical chessboard has 8 grids, but for the sake of this problem, it says that you need to place n queens in an n cross n chessboard. So you can assume a board which has many checks, many rows and columns, and you are given an input n. So that means it should have n number of rows and n number of columns. Let's see what happens when n is equal to 4. So when n is 4, it means we will have a checkboard with 4 rows and 4 columns. So it has 1, 2, 3 and 4 rows, and we have 1, 2, 3 and 4 columns. And we need to place 4 queens, maybe q1, q2, q3, q4 in this grid so that each of the queens can't attack each other. So let's go through the rules. Let's say I place q1 in this part. Now if I place q1 here, this q1 can attack anything in its column, and it can attack anything in its row. It can also move diagonally, so it can move like this and it can move like this. So this, and it can also move in the other diagonal like this and like this. So this means since q1 can move in this direction, it means it can attack the other queens present on those grids. So this means now that we have placed q1, we can't place any of the other queens in its path. So this cell, then this one, this, and these two cells. Now we can't place any of the queens in these areas. Now let's take q2. So where can I place q2? Let's say I place q2 here. So because this was the acceptable position, so now q2 can move in this direction, it can move in this direction, it can move here, and similarly it can move in this direction and here. So now these cells become ineligible for the other queens to be present. So now q2 is also placed. Next acceptable position for q3 is this. So let's place q3 here, and guess what? There is no place remaining for q4, because if q4 is placed, let's say here, it will get attacked by q1. If q4 is placed, let's say here, q2 will attack it, and if q4 is placed, let's say here, both q2 and q3 can attack it. So the question states that you need to place all the 4 queens on this grid so that it follows these conditions. The first condition is none of the queens attacks it. So what this implies for us, we can't place the queen in the same row or the same column or may also in the diagonal in which any queen is present. Now if you think logically what the right approach should be. So to solve this, you guessed it right, you need to find all the combinations, like you need to place each queen and check where to place the other queen, and by doing this you will arrive at the solution where you will know what is the right arrangement for those 4 queens. The question states that you need to find all possible arrangements for these queens. Now there can be multiple arrangements for q1, q2, q3, q4 to be present on this chessboard and not attack each other. One possible arrangement is, let's say I place q1 here and I place q2 somewhere here, and if I place q3 here and then q4 here, you can see none of the queens attack each other. If we talk about q1, it moves in this direction, so no queens are present here. Similarly, nothing here and nothing here as well. Talking about q2, it moves like this, so no queens are present here and here. Talking about q3, nothing is present here. This column is also empty. This diagonal is empty and this diagonal is also empty. And q4 also doesn't attack anyone. So this column is empty. There is nothing in this row. These 2 diagonals are also empty. So this is one of the arrangements. The second arrangement would be, the second arrangement is, let's say I place q1 here, I place q2 here, q3 here and q4 here. So all these queens are identical, it's not different, so I would rather name it queues. So I place one queue here, one here, one queue here and the other here. So these also don't attack each other, or they can't attack each other. These attacking positions are empty. So we need to find the solution. Now the question in Leetcode says, given an integer n, which is the number of queens and the number of rows and columns in our grid, return all distinct solutions to the n queens problem. Now it says the configuration of the n queen placement is denoted by q and dot, where q indicates a queen and dot indicates a space. So what this translates to is, this arrangement will be written as something like, so we mentioned all the position of queen as q and we mentioned the empty places with dots in our returned, in the result that we will return. So this will be represented as an array of strings. Yeah, so the first row is this, second row is something like this, third row is this, fourth row is this. Now since we need to find all possible combinations and place queens one by one, so we will use backtracking while using recursion. So backtracking is an algorithm which is built on top of recursion, where you use the result of the previous iteration in to get your final answer. So if you don't know recursion or what recursion is, you should probably watch my previous video where I explained about recursion. You will find the link in the I button above. Now let's look at the backtracking solution and how it will look like. We will create this board one by one. So yeah, let's start. So for the purpose of explanation, I will start with an example where n is equal to 4, and later we will generalize the approach. Initially, I will have a blank n cross n grid with all dots. So I will have an answer array which will be a list of two-dimensional lists. So each will be an n cross n list, and we will have array of that. So I start with this. Now I take one queue and I pass and I have a row which will indicate which row I am in. Now this is the 0th row, this is 1, this is second, this is the third index. So I will start with row as 0 and I will place the first queen here. So I will have something like this. Let's say I place the queen here. Right now I can't place any other queen in this row, so I move to the next row. I go to row is equal to 1. Now when I go to row is equal to 1, I will first check for this position. Is it safe to put the queen here? So I will have another function called is safe. This will take this board as input and the position. So I will have the row and column, and it will return true or false. So first I will call this position where row is 1 and column is 0, and is safe will tell that no, it is not safe to put the queen in this position because there's a queen which can attack this. So next I will try for the next column. So this is row 1 and this is column. So next when I try for the first column, I check for this position. Is it safe to put the queen here? I get no because this queen can still attack me. Then I will put column as 2 and I see that yes, this is safe. This is a safe place. Now that we have placed the second queen here, we need to place the third queen. For the third queen, we increment the row, and once we are here, we will check like is this position safe. We get no since the first queen can attack. Similarly, the second queen can attack in these positions. So the second column is also not safe. The third column, this queen can attack in these directions, and in the fourth column, this queen can attack in this direction. So none of these columns are safe, and since we could not place any queen in any of the columns, we can assume that our solution doesn't exist, because if a queen was not placed in a row for different columns at all positions, it means any other row has to have two queens, which is not possible, because if a row has multiple queens, they can attack each other. So here we can end our recursion, and we can say that the placement of this queen was invalid. So the solution where we place the second queen, this is not correct. Now this can have another possibility, like here we had checked till this column. Now we can also place the queen in the other column. We had q1 here. This position was safe, but it did not get us the answer. We had checked the placement of the second queen for these three positions. This fourth position we check, that yes, this is safe. So we place the second queen here, and then we move to place the third queen. Now the first queen can attack these places. So these cells are off limit. So for the third queen, we are moving to the next row because we can't place anything here. So the first safest place is here. We can place the third queen here, and let's see how it plays out. After placing third queen here, we will move to the next row and try to place our new queen. Now for the fourth row, this place is unsafe because queen 1 can attack. This place is unsafe because this queen can attack. Here also this queen can attack, and for this the queen in the second row can attack. So none of the places are good for the fourth row. So this solution is also not good. So this will return empty. And what this tells us is we can't place the second queen at this location. Now queen 2 doesn't have any where we can place it. So this means the position of the first queen was not correct. Now there are different ways we can place the first queen. Let's take an arrangement where we place the first queen. From the blank board, we will start a new placement for the first queen. This position was unacceptable. Let's try what if the queen is placed here. Now we looked at this row. Now we will look at the second row, and we will try to place the queen here, which is not possible since the first queen can attack. The first queen can attack these three positions. So the safest place for my queen, second queen, is here. Now after this we will move to the placement of our third queen, and now we are in the third row. Now is this position safe? Yes, this position is safe because the first queen can attack here, this path and this path. It can attack this path and these paths. The second queen can attack these horizontal and vertical paths. So this position is absolutely safe. So this works for us. Now moving further, we need to place our fourth queen. Now when we come here, we see that the queen above can attack these two places. The first queen attacks these places. The second queen attacks these places. So this place is safe. So now we were able to place 4 queens here. So then it will return to our function that this is a safe place, and we will save this arrangement. So we will save this as dot q dot dot now this will be one array in our big list of arrays, and we will repeat the similar process for other things. Now this is actually our answer array, and we will enter this in the answer array and we will keep on updating. Let's code for it. From this you can see we need to create a blank chessboard first, which is basically a grid. As you can see here, we have to return it as a list of list. Now this is a list, and so I had created it as a two-dimensional array, but it will be like this will be one string, this the second, so this is actually a 1D array with list of different strings. Now from I to n I iterate over the rows, and j from 0 to n I iterate over columns. So board ij is this, like this can be board ij, which is board 0 comma 0. Same, this can be 0 comma 1, since this is index 0, this is 1, and so on. Now I will define my answer array. I have initialized it with an empty array list, and then I will initialize my starting row index as 0, since I want to always start from the first row. So as you can see, I will start from the first row and keep on checking for different columns. And then it will be my recursive call. I will pass in my chessboard and the row for which I want to check the placement, and finally my answer array, which will store my answer, and at the end I want to return the answer. And that's it for this function. Now we need to implement this queen function. Now, I have implemented it as static because I want to persist the result of answer when I return answer here. That's why static. It will use the same memory. Now I want to iterate over different columns. So for example, if I am in, let's say, the second row, I want to iterate over all the columns and check which column is safe and then proceed. So for that I will write the code. Okay, I also need to pass the length, or I can find the length by int n is right. Now for each column I need to check if the position is safe or not. So I will write if I have to create a function is safe, that will take board as the input. It will take row and my column as the input, and yeah, it will return me if it is safe or not. Now if that position is safe, I will just put q in that position. After putting q, I will recursively call this queen function to check for the next row. So this will check for the next row, as you can see. So once I place a queen, I will check for the next row. And once that call has been done, I can remove q from here, because in one row we can place q in multiple positions and we can check for each of them. So for example, at first I placed q here. Next time I can place q in the third column. So that's why I will remove q and let it try to place q in the next column. And as you know, each recursive call should have a base condition. So in this case, my base condition is if my value of row is greater than the number of rows, I should break it. So if my row is equal to n, because array indexes start from 0, so my row should always be less than n. If it reached n, means it has crossed the array. So if row is equal to n, I need to push some value in my answer array, answer.push, and it should be that string. So I will basically construct that two-dimensional array. See this array, this value I need to push into the answer array. So I will construct based on the board I have. I will just construct this. And so I need to implement two more functions, construct and isSafe. Let's start with construct. It is easy. So here I declared an empty array list res, and I declared a temporary string. I iterate through each row and I keep on adding the value to temp, and at the end I push temp to my original list of strings and then return the result. Now that I have finished construct, let me check. Let me write the code for isSafe. By the way, static will return void and isSafe should return boolean. It will take board as input. Now I am given a row and a column, and I need to first check if there are any queues in the column. Now I can be sure there can be no queues in the same row because of the way I have implemented the recursion. So let me first check for the column. For that I will run a for loop for and I is 0, I less than, and just declare n. plus plus. Okay, so since I'm checking for column, I should check from 0 till my row. Like this will check all the columns, all the rows above my position. So for example, I am here. I need to first check if there are any queens above this. So this piece of code will do it. And then I need to check if there are any queens below it. Well, I don't need to check that because I can be sure there are no queens below it because of the way I am implementing recursion. Like we are inserting queues row wise and no queues were inserted below this yet, so we don't require this. Now if board of I till column double equals to 2, I will return false, because it is not safe to keep the queue in that position. Now I need to check if there is anything in the left diagonal. So for example, I am placing my queen here. I should make sure that nothing is present in this direction. So for that, I will iterate over the for loop. So if you see the pattern, if I am at position 1 comma 3, I need to make sure there is nothing at 0 comma 2. So there is an offset by which we want to like decrease both I and jth element. So what that offset is actually, I will write int left offset is, and then I will put left. So what this will do is, I will check if board of row minus I and column minus I. So row and column we decrease it by 1, then 2. So if we decrease this row and column, like row was 1 here, column was 3, we decrease row by 1, so we get 0, and we decrease column by 1, we get 2. So we need to decrease this, and till what limit? Till it will be the minimum of both row and column, because we can't go more this side, otherwise we will have index out of bound exception. So that is my left offset. And yeah, and if both of these, if any of these is equal to q, I want to return false. Now same thing we need to do for right diagonal. I will just copy this, right offset will be limited by whatever is less the distance of this from the end or the row. So my math.min row remains constant, and instead of column, like here we could move 3 times in upward direction, but only 1 time due to this, so 1 was the limiting factor. Now let's say we are at this position, so this can move twice in the upward direction. So it is the minimum of how many columns are there and how many columns it is from the end and how many rows it is from the start. So it will be n minus column, but since the array index starts from 0, it will be n minus 1 minus column, and this will give you the result. So if this is confusing, you can like do a dry run on pen and paper and try to find out this is the correct assumption, and at the end we will return true, because if none of the queens are if none of the queens are above that position or in the left diagonal or right diagonal above, that queen is safe. So yeah, so now we have completed all our functions, and let's try to run it and check. I'm sure there will be errors, but we will solve them. This will be answer. This will be board, since board is the variable name. Says add. this will be row since my ith is defined by row. You know what, I can actually simplify this to write something like new string and board of I. So it will automatically convert the list of characters to string, and I can keep on adding it to temp. Well, this was my base condition and I should return after this, otherwise my loop will keep on running. For checking left diagonal and right diagonal, I actually started from I equals to 0 if board row I minus 0, but if I is 0, I get board row and column, which is like the current thing. So I should not check for the current part, I should check for if from I is 1. Not that it matters, but still. One major bug is here, like I is 1 is fine, because even if I is 0, it won't find Q in that position because we are checking. Now while checking the right diagonal, I actually tried board of row minus I, which will be the row previous to it, and I should check for the next column because I want to check this direction. So I will change it to column plus I. So here I used left offset, I should have used right, a mistake while copy pasting. And I get the correct result. So for n is 4, I get these. I can add my test case here. Let's add test case. I will put n is, let's say, 7 and run it. And for 7 I get a lot of different results. You can verify each of the results and you will find that it satisfies the condition. Now this is the full code. You can pause it and take a screenshot of it if you want to practice it, but I would suggest to try to code it yourself first. There's another version of the question which says that you need to return the number of possible arrangements. So in this question we were returning the actual arrangements, but in the second part you need to return the number of arrangements, which you can guess is simple. You need to return the length of the answer array. But there's a better way to do it. You can involve it in recursion and keep on incrementing once you hit the base case that row is double equal to n. That's it for this video. If you found this video helpful, give it a thumbs up and share it with your friends. Don't forget to subscribe for more coding tips and tutorials. Thanks for watching. Till then, happy coding. Bye bye.